friends. This, this presentation is prepared by the technical team of Gaia Bottle Engineering Company Limited, who have a lot of experience in supplying sulfuric acid plant equipment in 1985, with more than 8,000 equipment supplied across 39 plus countries. Today's topic is acid irrigation in drying tower of sulfuric acid plant. Principle of drying tower. On what principle drying tower runs? The drying tower's function is to remove moisture from incoming air using concentrated sulfuric acid, generally 98 to 99%. The driving force is the difference in vapor pressure. Concentrated H2SO4 has a very low water pressure, so it absorbs water from the air. What are the design considerations for drying tower? Drying towers are sized for the maximum expected humidity load, often in monsoon climates. Because during the monsoon, the humidity is maximum, so drying towers are designed keeping that in mind. Acid circulation rate. Operators must adjust acid circulation flow and acid strength control more aggressively in high humidity seasons. Cooling rule. Since absorption of water is exothermic, high humidity increases acid temperature rise, adding burden to acid coolers. What does it mean? More the moisture in the air, and acid will be, after absorption of this moisture, acid will be more dilute, and the heat temperature of acid exiting the drying tower will be higher. So it will increase the load on acid coolers. Seasonal performance variations. Plants in tropical humid climates often face reduced drying efficiency in monsoon periods compared to dry seasons. That is due to, so if the plant is not designed, drying tower and not designed keeping the maximum humidity in mind, then this problem will occur. Or acid circulation rate is to be adjusted for higher moisture, and that is not done, then it will affect the drying tower performance. Role of irrigation system in the removal of moisture from air. The acid irrigation system in the drying tower is one of the most decisive factors for ensuring efficient removal of moisture from the air, sulfuric acid, from air in the sulfuric acid plant. Here is the detailed breakdown. Impact on moisture absorption. Uniform distribution prevents dry zones in the packing where air could pass through without protecting acid, leading to bypassing and incomplete drying. Next is sufficient film thickness. Ensure an effective liquid layer for absorption. Too thin, poor contact; too thick, can channeling and poor mass transfer. So the film thickness should be just sufficient for optimum absorption of moisture. Cooling and removal, heat removal role. Moisture absorption is exothermic. Heat is released. Irrigation system circulate the acid at high flow rate to carry this heat to coolers. If circulation is low, local overheating occurs. Water vapor pressure of the acid rises, absorption of acid drops. Thus, the irrigation system doubles as heat management system also. So, what does it mean? It says that knowingly acid circulation rate is kept higher side, so that the temperature rise of acid is not abnormal during the absorption of moisture. Otherwise, at higher temperatures, absorption efficiency of moisture will drop. Best operating condition of drying tower. Keep the drying acid 98 to 99% at 45 to 40 degrees centigrade temperature. Above this, driving force drops fast. Why this work? In principle, lower acid temperature, much lower water vapor pressure at the acid surface. So the gas liquid humidity gradient is larger and drying is stronger. Absorbing moisture is exothermic. Expected 5 to 10 degrees centigrade rise above the tower, across the tower at moderate humidity, more in monsoon. Starting cooler, keep the DT of the acid less than 50 degrees centigrade, maintaining capacity and limiting mist. Watch points. If DT after dew point starts creeping up or final absorber mist increases, first drop DT inlet acid temperature, then check the strength and flow of the acid. Even if everything in process is normal, a certain quantity of mist will be generated in the DT. In DT, air flows upward in the packed bed, while acid is irrigated downward. The upward air flow fine acid droplets from packing surface or fine from spray nozzles, and then breaks large droplets into aerosols more than, 5 microns. Drying tower. Sulfur burning plants mechanically generate H2SO4 spray from acid distributor, which causes droplets to detain. Due to low temperature, no thermal generation of mist. Size of the mist is more than 2 microns. Typical mist load is 500 to 700 milligram per nm3. Metallurgical plant, in metallurgical off-gas plants, smaller mist size particles can be entrained from upstream gas incoming cleaning towers, especially during malfunction periods, and adds to the inlet load of the filter. It is also more than 2 microns, and typical mist load is 1000 to 1500 mg per nm3. Ambient air always contains water vapor. In the drying tower, strong sulfuric acid is used to absorb this moisture. Poor acid distribution causes channeling. Some zones of the packing get heavy liquid flow, while others are sharp, non-uniform drying. Hot spot in packing accelerates acid corrosion and reduces mass transfer efficiency. High acid dilution. Uneven absorption load causes localized dilution, dropping acid resistance below optimum. Incomplete drying of air. When this moisture